So we are recording this session, guys. I prepared about 46, 47 questions covering almost all the chapters in your textbook. That doesn't mean I was able to pick up every single objective and concept. I just picked up, the objectives that I think they're very important for you to know. I might have missed some other objectives, so just be aware of that, guys. I mean, there could be, some sections that I didn't cover because I only have 2 hours and I can do only that much, in 2 hours. I will be using the calculator throughout. So if your instructor requires that you do methods other than using the calculator, you might see things differently in this review, but you might also learn something new and how to use the calculator to solve problems. So we'll be depending on the calculator throughout this review to solve problems in all of the chapters. And in particular, in the chapters that have to do with hypothesis testing, I heavily use the calculator in my classes, and it will be demonstrated here as well. So let's begin, give you just an overview of what we have done in this course, and I'm hoping that this would be a useful one. First of all, you need to know, guys, the difference between a qualitative or quantitative. For example, the bank account number of the student in a class. Although the bank account number is a number, but it's just, we use it as a label. We don't use it to add it or subtract it or multiply it, so that would be qualitative. Now, the weights of cases loaded onto an airport conveyor belt, the weight, this is a number that we can add, subtract, multiply, we do whatever with it, so that falls under quantitative. All right. Now, number 3. At the local technical school, 5 auto repair classes are randomly selected, and all of the students from each class are interviewed. What sampling technique is used? We have 5 sampling techniques, guys. One is called the simple random sample. One is called the stratified. One is called the cluster. One is called systematic, and one is called convenience. What do you guys think that this technique is? So what we did from all the classes, we selected 5 classes and we interviewed everyone inside those classes. What do you think? What sampling technique this called? Still remember? Okay, it is a cluster. And let me tell you what the cluster works. So this is, you take the population, you divide it into segments like this, and then you go to one segment or more and pick everyone inside that segment and put in the sample. This is what we call cluster. Let me remind you what stratified is. Stratified, you divide the population into segments, and then you go to each segment and pick people from each segment and put them in the sample. So that's what's stratified. Whereas a cluster, you just go to one segment and say everyone inside that segment is going to be in the sample. And this is what it says here. You took 5 of the classes, there are more than 5 classes, and select all of the students in each class. This is what cluster is. Number 4, every 5th adult entering an airport is checked for extra security screening. What sampling technique is? When you create, guys, a system, I said I want to interview or I want to survey every 5th, every 4th. What do we call this one? Does anyone know? It's not a cluster. It's not stratified. This is not a simple random sample because you're selecting every 5th. So you're creating a system. So this is called systematic sampling technique. All right. Number 5. The weights in pounds of babies born at St. Mary's Hospital last month are summarized in the table. Here is and so you have a frequency distribution table, guys. The first question I'm asking you to give me the class widths. So if we give you a table on the test, you should be able to read it and answer questions. Do you guys know what the class width here is? The class width is the difference between two consecutive lower class limits. You do it vertically, not horizontally, guys. So if this was a multiple choice, we might put 6 minus 5 as an answer, but that's not the correct answer. The answer is 6.1 minus 5. And 6.1 minus 5, guys, is 1.1. Or you could do 7.2 minus 6.1. Or you can do 8.2 minus 7.1. So as long as you do it consecutive vertically, you get the correct class width. So this is the class width. We might ask you how many classes does this frequency distribution table have? It has 1, 2, 3, 4, 5 classes. And then I ask you to identify the lower and the upper limit of the third class. The third class, guys, will be this one right here. So that's the third class. So the lower class limit will be 7.2. And the upper class limit will be the higher number, which is 8.2. So this is the frequency distribution table question. Okay, number 6, I'm gonna just leave it till later. It says to construct a frequency distribution table. So if time permits, I'm gonna show you how to construct a frequency distribution table from scratch, just given the data set. We're gonna go to number 7. The number of home runs that Mark McGwire hit in the first 13 years of his Major League Baseball career are listed below. Construct a stem and leaf plot for this data set. Well, a stem and leaf, guys, since I see the numbers are all 2-digit and single-digit numbers, so the largest is 2-digit, we're gonna make them all 2-digit numbers so we can be consistent. And here's how you create a stem and leaf plot. You just do a vertical line and you put the ones on the right and the tens on the left. So we have 0, and then we have 1, 2, what's the largest number? It's in the 70s. 3, 4, 5, 6, and 7. So you gotta go through all of them. Okay, for 0, so we have 0, was it 8? 8. So that's the first one. 0, 9, that's a 9. 0, 9, that's a 9. Now see ones, do we have anything in the tens? No, so you leave it blank. Anything in the 2s? Yeah, 22. Anything in the 3s? 32, 33, 39, another 39 right here. 40s, I have 1, 49. And then I have a 2, 42. What else, guys? 50s, I have 52. I have 58. 60, leave it blank. And I have 70. And now, in order to complete your stem and leaf plot, you have to put a key, just for a reader to understand what you're doing. And you can put the key for a reader. 0/8 means 8. They just read it as 8. So this is for number 7. Number 8, guys, describe the shape of the distribution. We have 4 different shapes you need to know. Bell-shaped, which is a normal, scoot to the right, scoot to the left, and uniform. What do you think, guys, this one is? Is it rightly skewed, left, bell-shaped, or uniform? Uniform means it's the same height. Right, yeah, that is correct. So look at the tail, guys. It's toward the right. Okay, excellent. Number 9. The annual profits of 5 large corporations in a certain area are given below. Which measure of center, the mean or the median, should be used here? Look at the numbers, guys. You have to know that the median gets impacted by extreme values, gets affected by extreme value, whereas the median does not get affected by extreme values. Do you guys agree with me that there is an extreme value in here? And which one? If you agree, which one is the extreme value? It doesn't seem like it belongs there. The 1,280,000. Well, if there is an extreme value, you should refrain from using the mean. This is very, very important information that you are learning, guys. You might see something like that on the final. So when we have extreme values, outliers, we should not use the mean. So we will be using the median. And I'm just gonna put median because extreme values are present. And you can actually mention which one is the extreme value. It's this value right here. All right. Number 10. The cost in dollars of 10 college math textbooks are listed below. Find the standard deviation. Not only we're going to find the standard deviation, we're going to find the mean, we're going to find the median, we're going to find anything that we can do using the calculator. So let's show you how to do this on the calculator, guys. Just turn the calculator on first. You go to Stat, Edit, and let me make sure that my list is clear, L1. And then I'm going to enter the data. So just 70. I wouldn't encourage you to do that standard deviation by hand. It's a lot of work, guys. So you should not be doing that by hand. 69, 68, 70, 70. There you go. We put the data in L1. You can put it in any list. And then here's what you do next, guys. You press on Stat, you press on Calc, and you go to one variable statistics and make sure that you're selecting the right list, which is L1. Don't touch this one, leave it blank, and then hit calculate. And let me show you what the calculator gave us. It gave us the mean, sample mean, 70.3. It gave us the standard deviation, the sample standard deviation. He says that what we have is a sample. So S is the answer, will be 1.49. Now this one, the next one is a standard deviation, but for the population. If he tells you guys in number 10, find the population standard deviation, he treats this data set as a population, then your answer will not be 1.49, will be 1.41. But most of the time, guys, it is a sample, so it's S. Let me show you what else the calculator provided as output. It gives us the minimum number. It gives us the first quartile, Q1. It gives you the median, which is 70. It gives you the third quartile, which is 71. And it gives you the maximum, which is 73. So you can get a lot done in here. All right, so S here is 1.49. Find the Z-score for the value 93 when the mean is 92 and the standard deviation is 2. Here is the formula for the Z-score, guys. It's X minus the mean divided by the standard deviation. X is the value, mu is the mean, and sigma is the standard deviation. So the value is 93 minus the mean is 92 and divided by sigma. 93 minus 92 is 1 divided by 2, it's 0.5. And that's the Z-score. Any questions, guys? All right, we'll keep going. Now, this is an important question. You have a data that is a data set. It looks like it's not bell-shaped, guys. It's skewed to the left. You can agree with that because there is a left tail. And the question is, the three letters represent mean, median, and mode. Which one is the median? Which one is the mode? And which one is the mean? Let's start with the mode. It's the easier one to do. Which one is the mode, guys? The mode is the one that occurs most often. So what do you think? Which one is the mode? A. Very good.
It's A.
Now, let me give you this good piece of information, and then you should be able to tell what's the mean and what's the median. In a skewed distribution, the mean is always the closer one to the tail. So which letter is closer to the tail, guys? C or B?
C.
So that must be the mean. And this definitely is the median. So if you see something like this on the final exam, guys, and we give you CBA, for example, and tell you which is which, this one will be the mode, this one will be the mean because it's closer to the tail, and B will be the median. All right. The following data are the yields in bushels of hay from a farmer's last 10 years. Find IQR. IQR, guys, is the interquartile range, which is by definition Q3 minus Q1. Okay, in order to do that, you're going to need to key in the data. So let's stat, edit. I'm clearing my list, and I'm just going to do this one more time to remind the students how to do this. So 375, 210, 150. You could do this by hand, but it is faster using the calculator. 429, 189, 320, 580, 407, and then 180. And here you go, guys. So you just go to stat, calc, one variable statistics. We need a Q3 minus Q1. Q1 is 180 and Q3 is 407. So it is 407 minus 180 will be 227, and that's the answer. Next question. 11 high school teachers were asked to give the numbers of students in their classes. The sample data follows. Find the 5-number summary. Again, guys, the 5-number summary is the minimum, Q1, Q2, which is the median, that's the median, Q3, and maximum. I'm not going to do this because I've already done it twice. You just put the data in L1 and run one variable statistics. And to run one variable statistics, guys, you just go to stat, calc, and one variable statistics, and just hit calculate. And you guys, you can see the 5-number summary. They start right here. Like for the previous exercise, the minimum is 147, Q1 is 180, Q2, which is the median, 265, Q3 is 407, and the maximum is 580. You do the same thing for this one. A random sample of sale prices of homes yielded the following summary information. So this is the minimum. This is the Q1, 25th percentile. That's the Q2. Q3 is the 75th percentile, and that's the maximum. Comment on the home that has a sale price of 429,000. What do you guys think this is going to be called? What does it look like? The maximum is 273. Would you guys agree with me that this will be an outlier? Yep, you got it. All right, just 1 second. All right. Next question. Now we're reviewing probability chapter. The set of 36 equally likely outcomes is when you roll 2 dice, guys, these are the outcomes. You get 1, 1, 1, 2, 1, 3, 1, 4, etc. I'm listing all of them. What's the probability of getting 2 numbers whose sum is greater than 10? Okay, let's see. First of all, the denominator, guys, is all the possible outcomes. They count 36. There are 36. Remember that when you work with 2 dice, it's always 36. Now we want the sum to be greater than 10. Okay, let's see which pairs will give me greater than 10. This one, that's a 1. That's another one. That's a 2. And you guys agree 6, 6. So the answer will be 3 out of 36 or 1 over 12. That's the answer. Any questions here? Number 17. The table lists the drinking habits of a group of college students. If a student is chosen at random, what's the probability of getting someone who is a woman or a heavy drinker? Okay, we need the probability of a woman or heavy drinker. This is called the addition rule, guys. Probability of A or B. Let me write it down for you. It's a probability of A plus probability of B minus probability of A and B. That's the rule. My A here is a woman and my B is the heavy drinker. So let's do it. What is the probability of selecting a woman at random? The total, guys, is 390. So your denominator is going to be the grand total always. Okay, woman, how many women do we have here? 219. So it will be 219 divided by 390 plus, according to the formula, probability of a heavy drinker. Who can tell me what's the probability of selecting someone who is a heavy drinker? I'll help you with the denominator. 390. How many heavy drinkers do we have?
13 or 16?
16. Yes, that's a different review sheet. Some of my students are asking me. I'm gonna share it with all in a second, once before we finish the meeting, so you'll get it, no problem. And then minus the intersection, guys, of women and heavy drinkers. So look, this is how you find the intersection. Women, heavy drinker, they meet here at 11 minus 11. So your answer, guys, will be 219 plus 16 minus 11 will be 224 divided by 390. And if your teacher requires that you have a decimal place, you just divide. 18. You roll 2 dice and total up the faces. What is the probability of getting a total of 8 or 2 up faces that are the same? Okay, round to the nearest 100. You already have the data, guys. I already have the list. He wants getting a total of 8 or 2 up faces that are the same. Okay, let's look here. These are the same faces. That's a 1. We need a sum of 8. 2, 2, same faces. 3, 3, same. That's a 3. 3, 5, that's a sum of 8. So I'm just gonna list them here. So 1, 1 would work. 2, 2 would work. 3, 3 would work. 4, 4 would work. 5, 5 would work. 6, 6 would work. And now we need a sum of 8. 4, 4, it's already there. 3, 5, that's 1. 5, 3, that's another 1. There's 2 more, guys. 6, 2, and 2, 6. Your denominator is 36. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The answer is 10 over 36. That's how you do this one. All right, number 19. Number of discs are placed in a box and 1 disc is selected at random. We have 6 red discs, 7 yellow discs. In an experiment, a disc is selected, the number and color noted, replaced, we put it back, and then we select a second disc. So we did 2 actions, guys. One action is to select the first one. The second one is to select the second one. The next question is, are the events or the actions independent? Yes or no? So we have a total of 13 discs. We select one at first, we put it back, and then we select another one. Independent, I agree. And let me tell you why. Because the probability of the second event is not affected at all, because when you selected one disc, you put it back. So you're still working with the original 13 discs, no changes to probability. Let me tell you one word I can add here, and then I will make the events dependent. If I say we select one disc and we don't replace it, And now we don't have 13 anymore. We're going to select the second one. It's going to be selected out of 12, not out of 13. Then in this case, the events are dependent. But in our case, they are independent. All right, number 20. In how many ways can Iris choose 5 of 12 books to bring on vacation? This is a combination, guys. It's C. You have 12 books, and in how many ways you can choose 5 books? It's 12, choose 5. How do you do that on your calculator? Let me show you guys. You put the 12 on the home screen. You go to minutes. You go to probability, and you go to NCR number 3, and then you can put 5, and here you go. The answer is 792. Any questions, guys? Okay, I'm gonna move to the next page.
Does it matter which number you put first?
Oh yeah, it does. The larger number, the big set first, and then the smaller one. So you put the grand total first, which is the big one, and then how many you are choosing. Otherwise, the calculator will not do it.
Okay, thank you.
Yeah, classify the variable as discrete or continuous. Discrete, guys, means countable. 1, 2, 3, 4, 5. You can count them. Continuous means they can have decimals in them. We can have something that has decimals. Like number of students in my class cannot be continuous because it's either a 1 student or a 2 or 3. You can't have 2.5 students. So the number of bottles of juice sold in a cafeteria during lunch, what do you guys think of this one? Discrete or continuous?
Discrete?
I agree. Can't have 1.5 bottles. It's just sold. You sell the entire bottle, so you don't sell half of it. The heights of the bookcase in a school library, that anything, guys, that can be measured using a tool, we need a tool to measure it, it is continuous. And since the height, you need a tool to measure your height, it is continuous here. All right, now we're reviewing binomial distribution. 65% of men consider themselves knowledgeable soccer fans. So P, probability of success, is 65%. If 13 men are randomly selected, so N is 13, what's the probability that exactly 8 of them will consider themselves as soccer fans? So we need a probability of X equals 8. I'm going to be using technology here for the sake of time, guys. When you have a question like this and we have a binomial distribution, we use this formula to find the probability of exactly. See, that's the word, exactly. That's the formula that you will use. Let me show it to you. You just go to second variable and you go to scroll down, binomial PDF. You put the number of trials here. We're asking 13 people. Probability of success, we said it's 0.65. And what is the X value that we want is 8. And you press enter. And here you go. That's the answer. 2154. So for exactly, guys, you use binom PDF. And you put 13. You put 0.65. You put the 8, which is the question, and then you find the answer. 24. According to Federal Communications Commission, 70% of all US households have cable TV. So P is 70%. In a random sample of 15, so N is 15. What's the probability that at most 13 of them have cable TV? At most, guys, in math means the probability of X less than or equal to 13. So X could be 13, could be 12, could be 11. And the good news is the calculator has a function that deals with at most. So anytime, guys, you have at most, you can go to the calculator and run binomial CDF. Not the PDF, CDF. You put the N, you put the P. Oh, the N is 15 here. You put P, which is 0.70. and the value in the question 13. And let me show you how to do this. So you go second variables and scroll down, guys, until you get CDF. C stands for cumulative. Trial is 15, 0.7. The next value is 13. And here you go, 9647. You might have learned to do this in a different way, but as I told you guys, I'll be using the calculator so I can do this review and given time. The probability that a football game will go on into overtime is 12%. So P is 12%. In 200 randomly selected football games, what's the mean and the standard deviation? Here's the formula for the mean, guys. And I will provide my students with the formulas. I don't expect them to memorize them. Mean is MP and sigma is square root of MPQ. N, guys, is given, which is 200. And Q, let me tell you what Q is. Q is a probability of failure. So if 12% is success, failure is 100% minus 12%, which is 0.88. So to find the mean, guys, you just do mean equals 200 times 0.12. And to find sigma, you do square root of 200 times 0.12 times 0.88, and you get the answers. All right. And now we're going to start reviewing the good stuff, the normal distribution. This is very important stuff, guys. I think all instructors, just give a great importance, to this chapter. Okay, let me just grab a clean sheet of paper because I want to show you the work on a separate sheet of paper. Just 1 second. Find the area under the standard normal curve to the left of Z equal 1.25. That's exercise 26. Watch, guys. That's what he wants. This is the Z distribution. That's the 0. And 1.25 is somewhere here. He wants this area. If you're using the table, guys, you can simply just go and look it up, just in the table and find the area to the left. And the table is designed to give the area to the left, so you can simply just look it up on the table. But the way I do it, I use calculator. There is a formula that we use to calculate this one. It's called normal CDF. And what you need for this formula, guys, you need 4 things. You need the lower bound of the area. Where does the area end from the left? The upper bound, where does it end from the right? And the mean and the standard deviation. When you work with Z, the mean is 0 and the standard deviation is 1. So we need a left bound, guys. As you can see, this is the left bound here. But it seems like it goes on and on forever here. So we use here -1 million, just for the left bound. So we're going to put a -1 million. The upper bound is where the area, just ends from the right, which is 1.25. And then you put the mean and then you put the standard deviation. And let me show you on the calculator. Turn the calculator on. Go to second and variables. And it's number 2, guys. That's a very important formula. -1 million. Upper is 1.25. So always to the left, guys, when he says to the left, you start with -1 million. 0, 1, and then paste, which is 0.8944. So that's the answer. Now, if you have your table, you're going to get 0.8944. When you use your table, simply, you're just going to go to 1.2 right here. And then you're going to go to 0.05 and then see where the 2 values meet, and you're going to get, just the same, you're going to get the same value. Okay. But I'm using technology here. Number 27. A physical fitness association is including the My Run in its secondary school fitness test. The time for this event for boys in secondary school is known to possess a normal distribution with the mean of 450. So 27, guys. Mean is 450 and standard deviation of 40 seconds. Find the probability randomly selected boy can do the run in less than 358 seconds. So we want the probability of X less than 358 equals. We're going to be using normal CDF again. We're not going to change to Z-score, so I'm going to use the formula right away. Okay, as I told you, when you do a less than, that's to the left. And to the left, guys, you have to start with -1 million. That's your lower bound. Your upper bound will be this number because you can go as high as this number. But you don't put 0, 1 here because we're working with X, not Z. You put the mean and the standard deviation, 450 and then 40. And that should give you the answer. Let's show you the work. So you go second, variables, normal CDF. -1 million I already have there, 358. Mean is 450, guys. And standard deviation is 40. And here's the answer. All right. Next question, number 28. The length of time it takes a college students to find a parking spot in the library parking lot follow a normal distribution with the mean of 4.5 and a standard deviation of 1 minute. Find the probability that a randomly selected college students will take between 3 and 5.5 minutes. Okay, watch, guys. He needs a probability of X between 3 and 5.5. He gives you the lower bound and he gives you the upper bound, and he gives us the mean also, which is 4.5 and the standard deviation of 1. Okay, here's what you do, guys. You go to normal CDF, you put the lower bound, you put the upper bound, you put the mean 4.5, and you put the standard deviation, and that will just give us the answer. If you want to do this by hand, you need to change this one to a Z-score. You need to change this one to a Z-score. Go to the table and find the area. Go to the table and find the area to the left and subtract the two areas. But with technology, guys, you really don't need to do any of this. Normal CDF, 3, 5.5. What's the mean? 4.5. Look how straightforward it is, equal. And we'll give you the final answer, 7745. That would be the answer. One step, and you can get it done this way. All right, number 29. The board of examiners that administered the real estate broker examination in a certain state found that the mean score was 558, so that's the mean, and the standard deviation is 72. If the board wants to set the passing score so that only the best 10% of all applicants pass, what is the passing score? Okay, let me show you how to do this one, guys. Here he gives you the probability and he wants you to work backward and find X. Okay. We do this. Top 10%, guys, is going to be on the right. So that's the top 10%. And we need the X value right here. What's the mean? He says, the mean, he says 558. And sigma is 72. Definitely the top value, guys, has to be more than the mean if you are on top 10%. If you are top 10%, that means you score higher than the mean. Here's how you do it. There is a function called inverse norm built on the calculator. And I'm going to just go to this function and show you how to solve this question, 29. So watch, guys. You go to second, and distribute again. Same way you do normal CDF. You go to inverse norm. And look what this is asking us for. It's asking us for the area, mean, and standard deviation. Let me tell you what we mean by the area. It's asking you for the area to the left of the target. If this is the target value, and this is the area to the right, can someone tell me what would be the area to the left of the target? That's 10% on the right. So what would it be on the left, guys? Yes? 90%, that is correct. A student asked me for the difference between CDF and PDF. PDF for exactly X, CDF for at most. That's the one that we went through. So 0.90. Mean, guys, is 558. Standard deviation is 72. And watch, it's going to give you the X values. It's 650.27. So you put 0.90. Remember, area to the left, left area. 558, 72, and your X is 650.27. All right, that's 29. 30. This is very important question, guys. Central limit theorem. Please pay attention to this one. I don't think anyone would give a final exam without a question on the central limit theorem, which is normal distribution. The average score of all golfers for a particular course has a mean of 67 and a standard deviation of 3. Suppose 36 golfers, N, played the course today. What's the probability that the average score of 36 golfers exceeded 68? Exceeded, guys, means more than 68. Okay, here's what he wants here. He wants the probability, not of X. He says their average score. Average means the mean, X bar greater than 68. Okay. So greater than 68. Let me show you a sketch, guys. This is 68. Greater than 68 means 68 and up. That means this is your lower bound. Start with 68. Your upper bound, the sky is the limit because this curve doesn't touch the x-axis and keeps going. So we'll use 1,000,000 here. So it will be normal CDF. You put 68 as a lower bound. You put 1,000,000 as an upper bound. You put the mean, which is 67. But look here, you have to pause here. A lot of students are going to put 3 here and try to solve it, and that would be wrong. When you work with samples, guys, the standard deviation changes. It's not the 3. It's a 3 divided by the square root of the sample size, which is 36. So the sigma we're going to be using here, it's sigma over square root of n. And this is the central limit theorem, guys. So I don't put only 3. I put 3 divided by square root of 36. Where did I get the 36 from? That's n right here. Okay, and let's show you how to do the math right here on the calculator. Turn it on, clear everything. Second and distribute. Normal CDF. Okay, lower. We agree the lower is 68. The upper is 1,000,000. Put as many zeros as you want. The mean is 67. And the standard deviation, look, guys, you put 3 divided by square root of 36. We know it's 6, guys. So I'm just going to put 3 over 6. And here's the answer, 0.0228. So when you work with samples, guys, don't use the original standard deviation as a standard deviation. Use the standard deviation, but divided by the square root of the sample size. This is what we call sigma of x bar. Okay, so that's a review for the normal distribution chapter. Any questions, guys? Let me see if anything in the chat. All right. Okay, let's keep going. Next question. Now we're starting with inferential statistics, confidence intervals. 31. A survey of 500 non-fatal accident. So that's N. Showed that 142 involved uninsured drivers. That's X. Construct a 99% confidence interval. The confidence level is 99%. For the proportion of fatal accidents that involved uninsured drivers. Okay, this is a confidence interval for the proportion, guys. And what we use this feature, 1 prop Z interval. Again, I'm not gonna do the work by hand, guys. I'm just gonna show you how to do it using technology. Otherwise, it will take me 10, 15 minutes just to do this one. So I do allow my students to use technology throughout. I'm not sure about other instructors, but they should. So here is how you use the calculator, guys, to construct the interval. Watch. You go to stat. So now, from now, probably till the end of this session, we're going to be using this feature, tests. You go to tests and scroll until you see 1 prop Z interval. Proportion. Prop means a proportion. Right here. Okay, you see, X is what? 142. N is 500. And 99. Calculate. And that's the interval. Let me write it down. P is between 0.2321 and 0.3359. And that concludes the question. Now, if the question asks you to interpret the interval in words, here's what you say. With 99% confidence, we can say that the true proportion of fatal accident involved uninsured drivers is between 23% and 33.59%. Any questions here? 32. A local bank needs information concerning the savings account balances of its customers. A random sample of 15, so N is 15. The mean balance was 686.75. With a standard deviation of 256.20. S. When do you put sigma as a standard deviation? If he says population standard deviation, since he didn't mention that, guys, it's S. This is very important to distinguish between S and sigma, and I'll tell you why in a second. He wants a 98% confidence interval. Assume that the account balances are normally distributed round to the nearest cent. Okay. This is going to be an interval for the mean. And actually, let me show you where to find this on the calculator. So you're going to go to stat, tests. And look, guys, we have at the bottom here, Z interval and T interval. Students, by mistake, they see the first one and they rush to it. And let me show you, if you do this one, what's going to happen. It's asking you for sigma, but we were not given sigma, guys. We were given S. Only if he says a population standard deviation. So I'm gonna just quit that one and go tests and show you T interval, which is the correct choice. And we don't have data, so it's just select the stats. And look, it's asking you for X bar, S, N, that's what we want. So X bar is 686.75. S is 256.20. N, guys, is 15. And don't forget the confidence level, which is 98. And then I'm going to hit enter. And there you go. This is an interval for the mean. So you don't put P, you put the mean between. He says to the nearest cent. So I'm just going to do it to the nearest cent. 860.36. That is the interval, so we use T interval here. if he asks you, if your instructor asks you to interpret the interval in your own words, you say, with 98% confidence, we can say that the true mean balance is between $513 and $860.36. Any questions? All right. Just let me pause for 1 second, please. Next question. So I'm gonna get the next one ready. 33. 15 randomly selected men were asked to run on a treadmill for 6 minutes. After 6 minutes, their pulse were measured and the following data were obtained. Construct a 95% interval. Okay, for this one, guys, you need to enter the data into a list first. And I'm assuming nobody will ask you, no one will ask you to do this by hand. It will be a nightmare to do this by hand. It's a lot of work. So let's enter the data. Okay, I'll remove the calculator. If you have your calculator handy, guys, just do that with me, because if you do it, you won't forget it later. So I'm just keying in the data. I'll show my calculator once I finish. And I would review my data set, guys, before I start doing the work, just to make sure that you didn't miss anything. I do make mistakes sometimes myself, so there you go. And now he wants a confidence interval for the mean. It's a T interval. So you go to stat, tests, T, it's always T interval when you have a data set. But now we're gonna select data because I don't have the summary, I have the data. I put him in L1, so I'm good. And he wants 95. You just simply put 95, guys. And here's the interval. The mean is between, let me just write it down, and then we can check which answer we're gonna select. 107, 114. Okay, I think it's this one. 93.7, 107.2, or 0.1, yeah, if you round it. Yeah, that's the one. We are 95% confident that the mean pulse rate of men after 6 minutes of exercise is between, let's send that. All right. Now the good stuff, hypothesis testing, guys. Yeah, been going a little bit fast, with the other chapters, so I can spend time here. The mean age of lawyers in New York is 51.2 years. Write the null in the alternative hypothesis. So HO will be mean equals 51.2, and this is the claim. Sometimes the claim can be in the null. And HA or H1, some other books call it H1, mean is not equal to 51.2. So that answers the question. 35. The mean age of principal in the local district is 45.5 years. So they say mean is 45.5 years, and that's actually the claim. So what would be H1 or HA? Mean is not equal to 45.5. If you perform a hypothesis test, what would you say if you reject the null hypothesis? If you reject the null hypothesis, guys, and the claim happened to be in the null hypothesis, you reject the claim because the claim happened to be in HO. So you just say there is enough evidence to reject the claim. Where is this language is, I can see it in B. There is sufficient evidence to reject the claim. All right. Let's look at 36. The mean age of judges in Dallas is greater than 53.8. Okay, so now HA or H1 mean is greater than 53.8. This is where the claim now. It's not an HO anymore, it's in H1. You perform a hypothesis test and you fail to reject HO. What do you say? if you fail to reject HO, guys, you start with there is not enough evidence. So if I were you, I'd start looking where does it say there is not enough evidence. It's C and D. Now, the challenge for you guys is to choose, is it the support word or the reject word? Since the claim is in H1 or HA, you choose the support word. So you say there is not sufficient evidence to support the claim. When you don't reject HO, you cannot support the claim if the claim is in HA. So there is not sufficient evidence to. Notice here, guys, when the claim was in HO, we looked for the word reject. When the claim is in HA now, H1, we look for the word support. 37. Now we're gonna do an actual hypothesis test problem. An airline claims that no-show rate for passengers is less than 5%. Okay, so let's do this one on a separate sheet of paper. That's number 37. HO, H1, no-show rate, so it's a percent, P, less than 5%, 0.05, that's the claim. Now, for students who are taking classes on campus, the null hypothesis will be greater than equal, the opposite sign right here. But for students who are taking the class online, they just use equal instead. So either one is fine. I don't want you to be confused here. But what matters to us is we know that the claim is in H1. In a sample of 420, so N is 420, 19 were no show, so X is 19, number of successes. At alpha equals 0.01, test the claim. So we're gonna test the claim. Let me show you how we're gonna test this one. This is a proportion, a claim about a proportion, guys. So we use one prop Z test to test it and find the p-value. So let's show you how we're gonna perform this one. Okay, you go to set, you go to tests, and one prop Z test. It's number 5, guys. Okay, you put the 0.5%, 0.05. That's the value in the null hypothesis. You put the X, which is 19. You put the N, which is 420. Okay, here, you put the sign that you see in the alternative hypothesis. And what sign do you see in the alternative hypothesis? Less than. You do less than. All right, and then you hit calculate or draw. It's up to you guys. Let me just do a draw. This is the p-value. Okay, so when you perform a hypothesis test, there are 5 steps, guys. You need to perform the 5 steps. The first step is state the null and the alternative. The second step is to find the test statistic Z, which is negative 0.45. This is where the calculator does the work, and we need the p-value. And here's the p-value, guys. That's the most important value here. It's 3272. Now compare the p-value with alpha. It's bigger than alpha, as you noticed. So if p-value is more than alpha, you fail to reject HO. And if a p-value is less than alpha, you reject HO. Remember that. If you fail to reject HO, you cannot support the claim because the claim is in HA. So you say there is not enough evidence at the 0.01 level of significance to support the claim. And you can write down what the claim is. All right, so that concludes this question 37. That when I say write down what the claim is, that the no-show rate is less than 5%. Next one, 38. So what we did here, one prop Z test. Test the proportion. 38. A shipping firm suspects that the mean life of a certain brand of tire used by its trucks is less than 39,000 miles. So guys, you already know what the claim is. Mean is less than 39,000 miles. I'll do it on a separate sheet of paper. To check the claim, the firm randomly selects and tests 18 of these tires, so N is 18, and gets a mean of 38,350. X bar is 38,350. With a standard deviation S. He didn't say population standard deviation, so it's S, 1200. Alpha is 0.05. Test the claim. Okay, let me show you how we're gonna test this claim. And I'm gonna show you the 5 steps, guys. Very important one. 38. You put HO and you put HA. Mean is 39, less than 39,000 miles. That's the claim. Okay, for the null will be mean greater than or equal, or for students who are taking asynchronous classes, you just simply put equal here. That would be fine. Okay, we're gonna run t-test. When it is a test for the mean, guys, you just run a t-test. So it's gonna be a t-test. Let's run the t-test and show you how to do that. You go to tests. And let me tell you the difference between z-test and t-test. Z when he gives you population standard deviation, T when he gives you sample standard deviation. So for us, it's gonna be a t-test. And we have a summary, stats. Okay, and look, mu0 is what do you have in the null hypothesis? I have 39,000, just put it there. X bar, guys. What is X bar? 38,350. S is what? 1200. N is how many did we select? 18. And now, guys, before you hit calculate, you need the alternative sign, the sign in the alternative hypothesis, which is less than. Make sure to select it properly. And then you can do calculate if you like. Let's do calculate, it's faster. Okay, all we need, guys, the next two values, T and P. So T is negative 2.298. And now P value. So I'm not using the critical value method with the review today, guys. I'm just using the P value. Okay, and what was alpha, guys? It was 0.05. Let's compare this with alpha. So what do you think? Is this bigger than alpha or smaller than alpha? Let's see what you put in the chat. Smaller. Okay. Yeah, I have a request to go a little bit slower. Unfortunately, if I go very slow, I won't be able to finish everything, but I'm gonna make the video available, guys, so you can rerun it at the spots where you need help with. So that's less than alpha. I'll try to slow down a little bit. We reject the null hypothesis. When the p-value is less than alpha, we reject the null hypothesis. And if you reject the null hypothesis, guys, you support the claim if the claim is in HA. So you say there is enough evidence or sufficient, you can use the word sufficient, at the 0.05 level of significance to support the claim. So this is how you perform t-test, testing the mean. Testing the mean. It's very important test, guys. I'll be surprised if any final exam will not have a question about the mean, testing the mean. We're gonna have probably one. Okay, 39. Now we're testing two means together, mu1 and mu2. A history teacher believes that students in an afternoon class score higher than the students in the morning class. The results of a special exam are shown below. Can the teacher conclude that the afternoon students have a higher score than the morning students. Okay, so here, guys, we need to test that mu1 is greater than mu2, higher. The null hypothesis will be mu1 less than or equal to mu2. But if you're taking the course online, guys, you just put equal here because the book uses equal other than this, but both are okay. All right, what kind of test we're gonna use? We're gonna use two-sample t-test. It is a t-test, but for two samples. And let me show you how do we run this test, guys. Watch. Stat, tests, as I told you, everything is gonna be right here, and it's number 4. And watch, let's do some data entry together. X1 bar, sample mean from the first set, 87. S1, 6.3. N1, 41. Just before I continue, guys, let's say you make a mistake and you go to sample Z test. I'm gonna show you that you will know right away that you made a mistake. It's a wrong test. See what it's asking you for here? Sigma 1, sigma 2. I don't have sigma 1, I have S1, so you know it's a wrong test. So let's go back, step, test. 6.3, 41, N2, guys. X2 bar, 84. S2, 5.8. N2, 36. Okay, here we need a greater than sign for the alternate. So I'm just going to choose the third one. Now, guys, for pooled, here's how you decided that it's a yes or no. If he says assume population variances are not equal, it's a no. If he says assume population variances are equal, it's a yes. If he doesn't say anything, it's a no by default. So we're just going to use a no here. Here it says assume population variances are not equal. And let's hit calculate, guys. Okay. So step 2 is a test statistic. I'm going to write it down. T is 2.175. P-value, that's the big deal right here, 0.0164. Okay, I copy the p-value and I'm done. I don't need anything else from the calculator. Okay, alpha, guys, is 0.01. So actually this is bigger than alpha. And what would be the decision, guys, if the p-value is bigger than alpha? Reject HO or fail to reject HO? Yes?
Fail to reject.
I agree. Yeah, I will post the review, guys. So what I will ask you to do before you leave is just put your email in the chat, and I'll make sure to send you an email with the link. And before you leave, I will upload the file that I'm using right now so you can put it on your desktop as well. Fail to reject HO. There is not, when you fail to reject the null hypothesis, you start with there is not enough evidence at the 0.01 level of significance to support the claim. We're saying we cannot support the claim that afternoon students perform better than morning students. We could not conclude that. All right, guys, so that's exercise 39. And if you don't put your email, guys, here's what you can do. Just write this down. Because I might spell your email for whatever reason. If you don't receive an email, you just write me at this email address, sbazi@hfcc.edu. and ask me to send you a link, you know, to the review or the document itself. I'll be happy to do it for you guys. Corey. This is when testing the mean for two dependent samples. This is an important one, guys. Probably this is one of the hardest ones when comparing two means. How do you know if the samples are dependent or independent? Once you see a table like this, guys, with the subject before and after, you know that the samples are dependent here. So the table below shows the weights in pounds of 7 subjects before and after following a particular diet program. Does the sample evidence suggest that the diet program is effective in reducing weight? So we want to test the claim that this diet program reduces weight. Use alpha equal 1% level of significance. Okay, let me show you how to do this step by step. First of all, guys, you have to do the difference between before and after. 178 minus 171 is 7. 56, that's a 9. 188 minus 186, that's a 2. So it seems like the diet worked for this one. He lost 7 pounds, he lost 9, he lost 2. 186 minus 199, this guy it didn't work for, he gained 5 pounds. 174 minus 160, that's 14. This guy gained 2 more pounds. And 167 minus 155, that's a 12. All right. How do we test it? We need to test the difference, whether it is bigger than 0 or smaller than 0. That's what you do in this case, guys. If the diet works, guys, what would you want the difference to be? Greater than 0 or less than 0? If the diet works, that means you end up losing weight. Greater than 0. I agree with you, Don. Exactly. Here's a hint for you guys to know whether you're going to use a greater or not. What's the dominant sign? It's the plus. Look, plus, 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 plus. I would just take a chance and make it greater than. So here's how you set up your null and the alternative hypothesis. Mean of the difference greater than 0. That's the claim. And mean of the difference is less than or equal to 0. And for students taking the course 100% online, you put equal 0 instead of that. All right, and we're gonna run t-test. Let me show you how we're gonna do this. First of all, guys, you need to enter the data into your calculator. So let's do that. Stat, edit, clear. Okay, and let me enter the data. 7, 9, 2, -5. Look, the negative is right here, guys. Negative sign is right here. This is the negative sign. 14, -2, and 12. All right, and now go to stat, test, t-test. It's always a t-test here. Take a note, data, and take a note. You begin with 0. You have to put 0 here. You're testing against 0. L1, my data in L1, and now the alternative sign, guys, is greater than. You must select that one. And if you like to see the p-value in action as a visual, I'm gonna draw it for you. It's gonna show up on the right if there is a p-value, big p-value. There you go. So T is 2.074, and the p-value, guys, is 0.0471. So I'm just gonna continue on a separate sheet of paper so you can see what we're doing. Number 40. So T is 2.074, p-value is 0.0417, and let's see what alpha is. 0.01. So that's bigger. So fail to reject HO. When you fail to reject HO, guys, and your claim is an H1 or HA, you don't support the claim. There is not enough evidence at the 0.01 level of significance to support the claim that the diet is effective in lowering weight, reducing weight. It's not effective according to our findings. All right, so that's number 40. 41, very important question, guys. Please pay attention to 41, extremely important. Might see something similar to that. In a survey, 46 of 145 women said they regularly remember their dreams. So 46 out of 145, that's women. 40 out of 140 men said they regularly remember their dreams. That's men. Does this constitute sufficient evidence to conclude that women are more likely to remember their dreams than men? I'm gonna restate the question in different words, make it easier for you. Is there enough evidence to conclude that the proportion of women who remember their dreams is higher than the proportion of men who remember their dreams? So P1 and P2, it's a proportion test, guys. We have P1, so we're gonna use P1 for women, P2 for men, and we need to test that P1 is greater than P2. And HO, guys, will be the total opposite. And for students taking the course 100% online, you put the equal instead of this. All right, we're gonna run 2 proportion Z tests. You're gonna see how easy it is to perform this test. 2 proportion, not 1, because I have 2 sets. That is how you do it. This is gonna be X1, and this is gonna be N1. This is gonna be X2, and this is gonna be N2, guys. You go to stat, tests. As I told you, we're gonna be here for the remaining of the session. Okay, X1, 46. N1, 145. X2, 40. N2, 140. N is a larger number, guys. Remember that. 40. We need the alternative sign, which is a greater. So I selected. And let's do calculate now. Go faster. Okay, I need test statistic and p-value. So Z is 0.58. And look at the p-value, guys. It's a huge. When the p-value is big, HO will stay. We cannot reject HO. So that's bigger than alpha. Fail to reject HO. And if you fail to reject HO, you don't support the claim. There is not enough evidence at the 0. What was alpha in this one? 0.05. At the 0.05 level of significance to support the claim. All right. So there is not enough evidence at the 0.05 level of significance to support the claim that the proportion of women who remember their dreams is more than the proportion of men who remember their dreams. Any questions about 41? So when you have 2 proportion, guys, this is the name of the test. Don't forget it. 2 prop Z test using the p-value approach. It's very, very important test. I cannot emphasize how important this test is. Very important. All right. Let's look at the next question. (42). Okay, I think we're good with time. A random sample of 8 apples of variety A and an independent random sample of 13 apples of variety B yielded the following weights in ounces. Do the data provide sufficient evidence to conclude that the mean weight of apples of variety A differs from the, what do you think differs mean, guys? What sign you're going to be using here? From the mean weight of apple of variety B. Use alpha equal 10%. Assume the data come from normal population and population variances are not equal. Differs, guys, means not equal. So if I use 1 here, 2 there, we need to test that mu1 is not equal to mu2. Okay, here's what you're gonna do, guys. You're gonna put this data in L1 and that one in L2. So let's see. Let's do this. Stat, edit, and I'm gonna put the data. So if you like, guys, you put them in L1 and L2. Let me just do that. Clear. 3.7, 3, 2.7, 2.8, 3.2, 2.5, 3.6, 3.4. And now I'm going to do L2. There's more in L2, which is okay. I'm almost done. 3.6, 3.8, 3.6. Okay, we're going to be using a t-test here. When it is about the mean, guys, it's a 2-sample t-test. And let me show you how to perform the test. I have the data. Watch. So we're going to go to stat, test, 2-sample t-test. And now, guys, we're going to have to use data because I don't have a summary. So it says your list is in L1 and L2. I'm good here. Don't change those. Always leave them at 1, 1. And now what's the alternative, guys? It's not equal, as you can see right here. Not equal. Pooled, no, because he says assume population variances are not equal. So it's unpooled. And calculate. So T is negative 1.506. P-value. I do apologize to some students who are using a critical value more than p-value approach in their class. Just simply, I won't have time to go over both methods. I can do that. 1499. And that's bigger than alpha. Fail to reject. I didn't intend, guys, to prepare problems, so we failed to reject HO. It just happened that way, so that's okay. If you fail to reject HO, guys, you cannot support the claim. So you say, if you reject HO, you say there is enough evidence to support the claim. But if you fail to reject HO, you say there is not enough evidence to support the claim. And what is the claim? Like, I require my students to write the claim that the mean weight of apples of variety A differs from the mean weight of apples of variety B. Just cut and paste, guys, and that's it. Write it down. All right. So this is about testing the difference between two means. Now we're gonna test the goodness of fit test. This is the chi-square distribution. A teacher figures that final grades in the chemistry department are distributed as 25%, A, 25% B, 40% C, 5% D, and 5% F. At the end of a randomly selected semester, the following number of grades were recorded. Test the claim that the grade distribution for the department is different from expected. Okay, here's how we perform the goodness of fit test. We're going to be using calculator as well. So, number 43. HO will always be the distribution is as claimed. Whatever they give us, that's what we say HO. HA or H1 is a distribution is not as claimed or different from expected. Distribution of grades is not as claimed. And this is what the claim is, guys, because he says, test the claim that the grade distribution is different than expected. So the claim is in H1 or HA. All right. Now, how do we run a goodness of fit test? We need two types of value. We need the observed values, which they are given to us right here. We're going to put them in L1. We need the expected values. And we're going to put them in L1. What are the expected value, guys? The expected values are the percentages he gives us. Like 25% of the grades are A, 25% are B. I'm going to show you how to find the expected values. First of all, we need the total. The total, guys, if you add 36, 42, 78, and 61, 38, 140, 160. So N is 160. And let me show you how to find the expected values, guys. 25% A, so 25% of 160 are A's. So you just do 0.25 times 160. Then the next one for the B's, 25%. Then you do 0.25 times 160. Then for the C's, 40%. You do 0.40 times 160. And then for the D's and the F, 5%. 5 means 0.05 times 160. And then 0.05 times 160. And this is going to go to L2, guys. So L1, L2, and we're going to run a test called goodness of fit test. This is the test that we're going to be running. So let's show you how to do this. We're going to go to the calculator, stat, edit. I'm going to clear my lists and show you how to input the values. L1, let's copy what we see on the screen. So for L1, 36, 42, 60, 14, and 8. L2, the ones that I worked out here. 0.25 times 160. You can do the math separately, or you can just put them on the calculator, 0.25 times 160. But 0.25 times 160 is 40, guys. And then again, 40. 40% of 160 will be what? 64. Then 0.05 times 160, that's an 8. And that's an 8. Okay, now I have the values, guys. I'm going to show you how to run the test. Stat, test, scroll down, and it's called goodness of fit test. There you go, right here. It's asking you, are the observed values in L1? You say, yes, they are. Expected values in L2, yes. And now let me tell you what the degrees of freedom is. Degrees of freedom is number of categories minus 1. How many categories do we have here? 1, 2, 3, 4, 5. Minus 1, we'll just put 4. Calculate. And here we go. That's the test statistic, guys, 5.25, and the p-value is 0.2626. Hold on 1 second. So I'm back. So Test statistic is chi-square 5.25. P-value is 0.2626, which is bigger than alpha. And again, guys, because this is bigger than alpha, we're going to fail to reject HO. And if you fail to reject HO, you say there is not enough evidence at whatever level of significance. What was alpha here? I don't remember. Alpha, guys, was 1%. So not enough evidence at the 0.01 level of significance to support the claim. Okay, that concludes this question. This is the goodness of fit test. Okay, let's go to the next one. We got 1, 2, 3 more. This one. Okay, this is the independence test. When you test if two variables, chi-square test, but for independence. If two variables are related, dependent or independent. A sports statistician is interested in determining if there is a relationship between the number of home team and visiting team losses and different sports. A random sample of 526 games is selected and the results are given below. Test the claim that the number of home team and visiting team losses is independent of the sport. Use alpha equals 0.01. Okay, guys, here's how you state HO when you run independence test. HO will be variables. I'm just gonna write the generic, just words so you remember that. Variables are independent. And for H1, variables are dependent. Now, if you ask me what are the variables are the home team losses, visiting team losses, and the type of sport that he mentioned. Where is the claim here? He says, test the claim that the variables are independent. So our claim is right here, guys. Okay, that's where the claim is. We're gonna run a test which is called a chi-square test, guys. And please pay attention to show you how we're gonna use the calculator to run the test rather than doing this by hand. Okay, first of all, guys, you have to do to input the data into the calculator and show the calculator how the data looks like in a table. So we need a table format. Your calculator has a feature where you can display data exactly the way it looks like here using a matrix, what we call a matrix. A matrix is a table that has rows and columns. And how many rows of data would you have here? We have 2 rows of data. And how many columns of data? 1, 2, 3, 4. So we need 2 by 4. And let me show you how to use the calculator to do this. Stat, edit. So just go to edit. Sorry, let me just display the calculator here. Here's what you do. You press the second key, and then you press X inverse where it says matrix. And then you go to edit. Scroll to the right. And then you press enter. And then you make sure that you have 2 rows by 4. Well, it happened that I did an exercise. It has 2 by 4 here. So if it's not 2, let's say this is a 3, guys, you just go and type 2 and then scroll over, put 4, and then, okay. Now we're gonna do the data entry. Watch, guys. You just put them, enter them, 39, 156. Hold on a second. All right, so let's do the data entry. So we got 156, now 25, 83, 31, 98, 19, 75. All right. And now let me show you how to run the test. It's very easy now. You just go to Stat, Tests, chi-square test. Scroll down to chi-square right here. This is the independence test, guys. Take a note. We put the observed value in A. Calculator is going to generate expected values in B, but which we don't need. All we need just to hit calculate. And look at the test statistic and the p-value, guys. That saves you a lot of time from doing the work by hand, 3.29. And p-value is 0.3490. It's a huge p-value, which is bigger than alpha. And if the p-value, guys, is bigger than alpha, you fail to reject HO. And if you fail to reject HO, what do you say? There is not enough evidence to reject the claim. Why I'm saying the word reject now, I'm not saying the word support, because the claim happened to be what? An HO. So you say there is not enough evidence to reject the claim. So probably the claim is good. All right. Now, next one. This is Anova, analysis of variance. The time in minute to assemble a component for 3 different cell phones are listed below. Workers are randomly selected. Test the hypothesis that there is no difference in the mean time for each cell phone. When you compare 3 means, guys, like this, mu1 and mu2 and mu3, we use a test. It's called Anova. And let me show you how to set it up. First of all, this is how you set up the null hypothesis. Mu1 equals mu2 equals mu3. For students who are taking the course on campus or live without the drive, this is section 10.4. And for students who are taking it online, it's section 13.1. So you state HO mu1 equals mu2 equals mu3. HA, this is the generic language you put always here. At least one of the means is different from the others. All right, so that's what we put there. And now where is the claim? It says test the claim that there is no difference. No difference means equal. That's the claim. Okay, you're gonna put this in L1, L2, L3. So I'm gonna pause for a second to put the data and then I'll run the record. Here's the test that you do here. You go to Stat, Tests, scroll down to the very last test. Anova. And put second, and then number 1, comma, second, number 2, comma, second, number 3, comma, press enter, and you get the test statistic F, which is 7.10, and you get the p-value, which is 0.0074, which is less than alpha this time. So we reject HO. And what do we say? We say there is enough evidence at the 0.01 level of significance to reject the claim. Why am I saying the word reject, not support? Because the claim is in HO. To reject the claim that there is no difference in the means. So enough evidence to reject the claim. I hope you have a good understanding when we use the word reject, when we use the word support. The word reject is used when the claim is in HO. The word support is used when the claim is in H1 or HA. All right. Now we got one more question, which is about regression and correlation. This is a chapter 9 for students studying from Larson book. And this is a chapter 4 from students studying online. So I'm going to do the last question. That should take me about five minutes, guys, and we will be done. But before I do that, I'm going to pause recording so I can enter the data, and you do the same thing at the same time. put the age in L1 and the pressure in L2. You have to do that. The data below are the ages of systolic blood pressure measured in millimeters of 9 selected adults. Find the correlation coefficient R and interpret its meaning. Here's how you find the correlation coefficient R, guys. You press second, stat, calc, linear regression, AX plus B. Make sure you select the right list. Mine is L1 and L2, so I need to change second and number 2 and calculate. So R is 0.96. You can see that. If R is very close to 1, guys, you can conclude that there is strong positive correlation between the variables. If R is very close to -1, you can conclude that there is strong negative correlation between the variables. If R is close to 0, you say that the correlation is weak. Here, R is 0.96. You're going to say that there appears to be very strong linear positive correlation between the variables. All right, so that's the answer to part A. Part B, find the equation of the regression line. You already have it, guys. It's right here, AX plus B. A is 1.49, X, and B is what, guys? 60.46. Okay, just 1 second. So this is the equation of the line, guys. Y equals AX plus B. A is the slope and B is the y-intercept. Now, if your calculator, guys, doesn't show R and R squared, here's what you have to do. Let me show you what you have to do. You press the second key and you press number 0. And then it's going to open the catalog. You scroll down in the catalog until you get diagnostic on. And make sure it's selected. I'm going to show you. Because if you reset your calculator, this will go away. You need to do it. Here you go. Diagnostic on. Enter. Enter. Once it says done, you're good. So if I go back to stat, calc, number 4, L1, L2, calculate, and here you go. That's R. Equation of the line. Now the C, he says, estimate the systolic blood pressure for someone who is 54 years old. Okay, you have the equation, guys. This is the equation. And he says X is 54. You just plug it in here. So what would be the blood pressure? 1.49 times 54 plus 60.46. Just use the calculator to do the calculation. So 1.49 times 54 plus 60.46. It will be, what did I do? 1.49, sorry. No one would live if they have a blood pressure in the thousands. Plus 60.46. I got 140.92. It's about 141. All right. And test the claim at the alpha 0.01 level of significance for positive correlation. Here's how we set this up, guys. So we just got this part and we'll be done after HO, HA. We test the population correlation coefficient rho positive. He says test for positive. So this is where the claim. And here for students using Larson, you just put less than or equal to 0, and other students just put the equal there. Now to do this test, guys, we go to linear regression t-test. I promise this is the last test I talk about today. And look, guys, you go to stat, test. So this is the test to test the correlation right here. Watch it. Enter. L1, L2, we're testing for positive, guys. So choose positive here, greater than 0, and hit calculate. And look, this is the test statistic T. which is 9.0335. And look at the p-value. A lot of students, guys, ignore the -5 here. The -5 means you have to move the decimal 0.5 digits to the left. So actually the p-value, guys, is 0.00002, which is less than alpha. So p-value you reject HO. And when you reject HO, guys, you support the claim. So you conclude that there is enough evidence at the 1% level of significance to conclude that correlation is significant, or that there is positive correlation between age and systolic blood pressure. So support the claim. The last question, find R squared and interpret its meaning. Well, guys, you already have R squared right here. Even when you run the test, you will get R squared, which is 0.92. Let me show you how to interpret R squared. Here's how you interpret. We say 92% of the variation in systolic blood pressure can be explained by the variation in age. Using the regression line. So 92% of the variation in systolic blood pressure, so 92% of the variation in the Y variable can be explained by the variation in the X variable. That's how you interpret the meaning of R squared. R squared, by the way, guys, it has a different name. It's called coefficient of determination. So on the test, guys, if we ask you to find the coefficient of determination, this is R squared. And if we ask you to find the correlation coefficient, that's R. All right. So that's everything. That concludes the entire thing. So I'm going to stop the recording.